According to the INTRNACHI Home Inspection Standards of Practice, the home inspector shall inspect the service drop, the overhead service conductors and attachment point, the service head, gooseneck and drip loops, the service mast, service conduit and raceway, the electric meter and its base, service entrance conductors, the main disconnect, panel boards, circuit breakers and fuses, service grounding and bonding, a representative number of switches, light fixtures, and receptacles, including receptacles observed and deemed to be arc fault circuit interrupter protected using the AFCI test button where possible, all ground fault circuit interrupter receptacles and circuit breakers observed and deemed to be GFCIs using a GFCI tester where possible, and for the presence of smoke and carbon monoxide detectors. The home inspector shall describe the main service disconnect's amperage rating if labeled, and the type of wiring observed. The home inspector shall report as in need of correction deficiencies in the integrity of the service entrance conductor's insulation, drip loop, and vertical clearances from grade and roofs, any unused circuit breaker panel openings that were not filled, the presence of solid conductor aluminum branch circuit wiring, any tested receptacle in which power was not present, polarity was incorrect, the cover was not in place, the GFCI devices were not properly installed or didn't operate properly, and other problems related to the electrical receptacles, and the absence of smoke and carbon monoxide detectors.
Now we're going to look at 3.7, which is the electrical system. It starts with your service. So on this house, we have an underground service. It's actually marked right there because they had somebody mark the yard. First thing we want to do is pull on our meter tag. If it comes apart or if it's cut, we want to write that up as a defect. You can tell somebody's painted one and not the other. It makes me think at some point this has been replaced. Looking, our nipple there, we have wiring run, looks like over to the garage in conduit. So we want to make sure that's always in conduit. Open this up. We want to make sure we're not too high above the ground. Now, looking at this, looks to me like we're missing some of our legend. 1, 2, kind of mismatched. So I would write this up. One is missing a dead front cover screw. Missing or not labeled completely. Now remember, we wanted to look at the air conditioner, see what our data tag was to see if we had the right breaker. 25 amp, that was rated for 20 to 40, so we're okay. Now, standards of practice, we are not required to open a dead front cover, but we are allowed to open a dead front cover. So typically, this is how we're going to tell what our service wires are, what our 120 wires are, and what our 240 wires are. So if it is safe and you are comfortable, it is always best to open up the dead front cover. There are a few states and jurisdictions that do not allow home inspectors to do this, however. So you need to check with your local jurisdiction and your standards of practice for your state. Remember, safety is always priority. There's more items in an electrical panel to report on than anywhere else in the house, but it also can be very dangerous if you're not careful. Now, normally we put on gloves and wear shields. For the video, that doesn't work so well. So today we're not doing that, but just understand you do want to wear your protection equipment. If I put it on, it's really hard to hear me talk, things like that. So we open up the panel. First thing we're going to do is take some pictures. Now, typically, we wouldn't see this by an electrician, this extra insulation. We are required to have at least 1/4 inch. So this is not a technical defect, but it just tells me we've had people in here that probably weren't an electrician. We're going to look, what are our service wires? They're aluminum. What are our 120s? Well, I'm seeing a lot of aluminum 120s there. Now, when we point, I either use my plastic stylus, or a lot of times we will also have a plastic pen. So if I'm going to show my clients a problem, I'm going to point to it like this. Don't use a screwdriver. You shouldn't get in the habit of using your finger. If you do, stay a long ways away. but a pin works really good. So, like I say, most electricians wouldn't leave this much insulation. We're using what's called fused neutrals. We have a bunch of neutral wires under one screw. Most panels do not allow that after 1996. Now, this is a 1971 house. So it was acceptable, but that area is prone to bad connections. So a lot of times we'll see scorched melted wiring when they do that. Here's our grounding and neutral bus bar because it's a main panel. Here is our bonding strap. So we want to look and make sure our bus bar on a main panel is bonded to the case. Then we're going to go down and look at our breakers. Do our wire sizes correlate to the breakers? On these, they do. 30 amp, 10 gauge. Here we have, that's copper on this one. That's a 14 gauge, so it's a 15. Now you'll notice these wires look really big. When you're using aluminum wiring, we have to upsize one. So a 20 amp uses the 10 gauge wire. A 15 amp would use a 12 gauge, unlike copper, which would be 12 and 14. So we want to look, make sure all the breaker sizes are correct for the wiring. Then we're going to come over here and look, do the same thing on this side. Now these are 15s, so these are 12 gauge because they're aluminum. 10 gauge, 25, that's okay. This is another copper wire, so it's 15 and 14, that's okay. And up here, 50 for the range, that's okay. So we have aluminum service wires, we have copper and aluminum for our 240s, and we have copper and aluminum for our 120s. So that goes in your report. Now, whenever we see aluminum wiring on our 120 circuits, you do want to call it out for further evaluation by a licensed electrician. We have had a lot of problems with aluminum wiring. So now they typically either recommend replacing the wire or redoing all the terminals with either copper aluminum crimps or Alumicons. So they also usually recommend putting antioxidant, which I don't see any here. Now, code does not require antioxidant. It allows you to do it, but a lot of jurisdictions require antioxidant. So we write it up when we do not see it on our connections. So we've looked at our wires, we looked at our bus bar, we looked at our service lugs. Now we're going to look at the shell itself. Do we have wire bushings? Are we missing knockouts? Newer electrical is now required to bond this nipple here. So on a newer service, we would expect to see a ground wire coming out of here. As we're looking here on this age, we have one ground. Looking to see if we have a driven rod. Here it is right down here. Goes underground, so we can't see it, but it's going through that conduit. Now, a lot of times we will have a water ground. So newer construction will have two ground wires coming out. One typically goes to either a ground rod or a UFR. The other will go to the cold water line. When we pull off the screws, we want to make sure they are flat tip screws. If that screw hits a wire, like right here, we want it to push that wire, not poke it. If it's a pointed screw, it can pierce it and actually short that wire out. So now, when we're done here, I would document what breakers are off. They have the AC breaker off, they have this breaker off, but it's not being used. So there are a few openings. We would take another picture, and then we would put the dead front cover back on. Now remember, standards of practice, we are not required to remove the dead front cover. Like I say, some jurisdictions do not allow it. When you can and when it's safe, it's a good idea because that's where we're going to see a lot of problems. Now, we keep extra screws in our bag just for that reason. If you drop one and you lose it, you want to be able to, make it right. I don't replace missing screws as a habit. I write them up as missing, but I do keep some extras that I buy at the hardware store that are the right screws for the right panel in my bag. Now the panel is old enough. We don't have any arc fault breakers. We also don't have any ground fault breakers, which would lead me to hope that we have GFCI outlets in the bathrooms and kitchens at the wet areas. Now, we did feed a sub panel, which I don't see where it's labeled on here. Like I say, they're not labeled completely, but that sub panel is probably for the basement because I saw it was in the basement. So we may have arc faults down there. I would take another picture that shows everything is exactly how I found it. Now, that initial picture is great because if you accidentally turn something off, you've already taken a picture before you touch this, so you know which breakers were where. So then you want to close the rain cover. And to those of you that aren't in Colorado, New Mexico, Arizona, or Nevada, it is very odd to see an electrical panel outside. Because of our lack of humidity, most of our panels are outside. But most places around the country, you're not going to see the panel outside like this. That's kind of a unique thing for us here. That's wrapping up the electrical panel. Now we'll move into the inside of the house. Okay, we just came from the main panel. I like to do all my panels at the same size. So when we did our initial walkthrough, we noticed that there was a sub panel downstairs in the mechanical room, laundry. So we talked about this briefly. First thing we want to look for is a legend. Okay, we do have a legend. We have our screws. On this one, we do have an arc fault breaker that we can test, but it's a GE panel. We've had good luck with GEs. So again, you're not required to pull this off, but it's a good idea. You'll notice I brushed it like this to begin with. That way, if it was hot or had a problem, your hands would go like this. It wouldn't be stuck. It would be like this. So since we're going to take this sub panel apart, and now understand, we call it a sub panel, but electrical codes call them all distribution panels. There is no such thing as a sub panel. Thing is, if you call it a distribution panel, most of your clients won't know what you're talking about. So we're going to take off the dead front. Notice I'm standing in front of the panel. We're supposed to have 3-foot clearance, basically floor to ceiling in front of any panel, and that's for safety. If I'm having to reach over something, it's not safe for me to take off the dead front cover, so then I definitely would not be taking it off. So we have our proper clearances in front. We've already checked it. So now we're going to take apart our dead front. And like I say, make sure your jurisdiction allows it. Some states, some SOPs do not. But for the rest of us, most of us are allowed to take off dead front covers. Now, we never want any wood contact, so we want to make sure, yes, it does come out all the way. So somebody just framed this out because there's not a lot of space here. So this is the sub panel, and it's in the house, which means it's attached. So therefore, we have to have a 4-wire system. So we have a hot, a neutral, and a separate ground. Because that is a 10-gauge ground, now, new standards, we cannot have over a 30-amp breaker. We're no longer allowed to overfuse our ground wires. We should also have an isolated, non-bonded neutral, so it can't be connected to the case. And then we have to have a ground that is connected to the case. So we have our grounding bus bar. We have our neutral bus bar. We have our main lugs. So we have a 240 circuit, 10 gauge. So we had a 30-amp breaker upstairs feeding this. Looks like we might have an overfuse. Let's look at that. No, we don't. So it's just a different age wire. This wire is a little thicker than this insulation, but they're both 12-amp breakers. Over here, we have our arc fault. 15-amp circuit. We have a 20 and a 15 here. So our breaker size correlates with the wire. Don't have any extra knockouts. We have our wire bushings. We have at least a 1/4 inch of insulation on those. This style here with that bushing, they terminate right there. You can actually see it right there. If this was a main panel, or if it was a detached structure that they wanted to use its own grounding system, right here it says bond. There would be a green screw right there. Some of the times the panel is shipped with that green screw and it has to be removed. So you always want to look for that bond screw. And with a sub panel, it typically shouldn't be there. On a main panel, it should. So now we're going to put the panel back together, put the dead front cover back on. Okay, you want to make sure you put everything back together, be safe, and remember, like I said, we're not wearing the safety goggles and that today because of the voice, but normally you want to wear your face protection, all of that kind of stuff to be safe. So you want to put your screws in, and remember, just like the main panel, we want flat tip screws. So now we're putting the sub panel back together. Now, once this is together, then we'll have to check a representative number of outlets. We'll have to check our smoke detector locations, our carbon monoxide detectors, and our lighting systems. Again, took another picture, show that everything's exactly where it was. We have everything back together. And so now we're done with our panels, and we'll start going our interior electrical. Right over here in the storage room, we see a missing junction box cover. Basement, storage rooms, garage, a lot of times you'll see where people have added things, and those are definitely areas along with the attic that you want to look for missing junction box covers, things like that. For interior electrical, we're required to test a representative number of outlets. We turn all the lights on as we're coming through. We'll know it like this, where there's a bulb burnt out, because it could be a bad fixture also, not just a bulb. So if there's something not working, we want to note it. But I like to test every outlet that we can easily get at. Like over here, I'm not going to unplug a TV. I'm not going to unplug a computer, things like that. There's two types of testers. You know, this one's $10. This one's a little bit more. If we're doing newer construction, a lot of times we'll just use this one. But if we're using a house, this house has aluminum wiring. So I like to get this out. If we're doing an older house, if we're doing a flip, especially because there's a lot of false ground, things like that, that this will find, that this won't. Now we do use this to trip our GFCIs. It's just a little faster than this. So we'll just come, we'll plug in. That tells me that circuit's good. Now the basement on this house doesn't have aluminum, but when we get to aluminum wiring, we'll check our voltages. And our voltage drops at 15 amps, because if I have a bad connection with aluminum, it'll show up with this. This here, it won't. It'll just show up like this. So we just go around. Like I say, I test all the ones we can get at. You're only required to do a representative. If you're going to do that, I would suggest you do at least one in each bedroom, or at least room. These Airwick type things, some of them have the oil in it. I would never unplug one to test it, because if you spill it, that oil or that wax leaks all over. So they tested good. Now, the other thing you want to look at is location of the outlets. Typically, we don't want to have any place that we have to have more than a 6-foot cord. So if it's newer construction, we should have quite a few outlets. Older houses, a lot of times we'd only have a couple outlets in each bedroom. So now this one, I'm not going to move the couch to get at. And in here, I'm not unplugging their things, but we have one right here we can test. We are going to run the ceiling fans as part of the electrical lighting system. So if they vibrate, we're going to call it out, things like that. It has a little bit of a vibration. I'd put it in the report. It's not too bad, though. Actually, it's settled down. It's probably just because I moved it by pulling on it. Now, coming into the bathroom. We are supposed to check all GFCIs. So I like to trip them with a quick tester. It's just much easier. Just check it. It reset just fine. And light came on. I was like, we have a Bluetooth fan. So we'll turn that one back off so we don't turn on anybody's stuff. But so just check that. And the rest of the outlets in here have things plugged in. They're just not easily accessible. Okay, now depending on the age of the house, you know, the house may or may not have GFCIs. When I look at these outlets, these are new outlets, so they should all be GFCI protected because of the kitchen. However, if you have a 1970s house with original outlets, they may not be GFCI'd. So we'll check these. Reset just fine. Check this one over here. Current standards are every outlet in the kitchen should be GFCI, which should be even like these down here. You're not required to take out outlet and switch cover plates. However, if they're off, you want to put it in the report. And it's actually a good time to look and see what's been done to the wiring. These were off when we got to the house. So I could look in here. Remember, the upstairs of this house has aluminum wiring. So as I'm looking right here, this device says this switch is rated for COALR, which means it's an aluminum rated light switch. They also make outlets that are aluminum rated. Now, if we look inside here, we see these purple connectors. Those are called Alumicons. They are endorsed by the Consumer Product Safety Commission for aluminum wiring. These red wire nuts are now no longer endorsed. Prior to 86, they were. But so my report would say the red wire nuts that were used to pigtail aluminum wiring did not appear to be currently rated for use with aluminum wiring. Now, it's on the ground circuit. You will see that quite often because these Alumicons and copper aluminum crimps are expensive. The wire nuts are pretty cheap. Since the ground doesn't carry current, a lot of electricians will put just wire nuts in the ground circuit. Now down here, we have the same thing.
Definitely.
And if I look,
items being checked on
says
this is really
COALR. So
that
that outlet is rated for aluminum wiring. If I looked and I had aluminum to it and it was not rated for it, said copper only, I'd put a note in my report that the outlets and light switches did not appear to be rated for use with aluminum wiring. Normally, we talked about this outside at the panel. When we have aluminum wiring, we want to see antioxidant. However, when we have the COALR, because of the base metal they use right here, when current is run through it, it off gases, and you're not required to use dielectric antioxidant grease on the connectors when you have a COALR outlet or switch. And like I say, remember, you're not required to take off the cover plate, but if they're missing, you do want to put it in the report. Okay, again, I like to check outlets in every accessible outlet in a room, but when they have things like this plugged in, that will make a big mess if you spill it. So I typically will not test this one, or if I do, I'll just test the other one, like that one. Now, that light switch is upside down. What that tells me is this top section is on a switch. So it's a switched outlet. The age of the house, that wasn't what was normally done. So somebody's changed that. Again, plugged in here. So I wouldn't test those. Both of the bedrooms did not have any accessible outlets. They had everything plugged into them. But the bathroom, we can check the GFCI again. So it's wired correctly. It trips and it resets. And comes on. So we've checked our electrical here. Smoke, CO, and a CO. So they've actually done more than they need here. We could have just got by with this. Great though to see more. And in the bedrooms, we have our smoke detectors. We are required to check for the presence of smoke detectors and carbon monoxide detectors. That's part of our electric inspection. And as you look in here, all we can really test is the light switch because there's just so much stuff we can't get at any of the outlets. So my report would say several of the outlets were not accessible due to the occupant's belongings. And that's where your original pictures would show in, because it said, well, you didn't, you know, you had a bad outlet in the bedroom. And it's like, yeah, look at this. I can't see anything in the bedroom. So that's where your pictures make a big difference. And then again, that room was locked, so we can't go in there. Okay, so we have completed the electrical inspection for the house. Now, this house did not have a fireplace, so we do not have a 3.8 section. So 3.9 is attic ventilation, roof cavity, basically. So that's where we're going to go to next.